Hello students, welcome back. Today we will solve some examples, right? Till now you had studied till parallax method, right? You have studied the theoretical portion of parallax method. Okay, so now we will study some of the examples till that topic. Okay, so let's start with example 2.1 of NCERT textbook. Okay, so the first example is calculate the angle in radian. Okay, so the first one is 1 degree. Now we had already studied the method of conversion of degree to radian, right? So, see, we know that 1 degree. First, let's solve. What was the method? 180 degree equal to pi radian. So 180 degree pi radian. 1 degree, how much? So simple cross multiplication, 1 into pi upon 180 degree. You can take pi as 22 by 7 or 3.14. Okay, so let's finish it in short. 1 into 3.14 divided by 180. Clear? So what will be the answer? Let me calculate it. 180 divided by, sorry, my mistake. 3.14 divide by 180. This is equal to 0.174444. So this will be equal to 0.174 radian. Clear? So it's very simple. 180 degree pi 1 degree, how much? So it's 1 into pi upon 180 cross multiplication. So 1 into 3.14 divided by 180. This is equal to 0.174 radian. Okay. Now let's move to the next one. 1 minute. See, now we have the conversion from degree to radian, not from minute. So what we have to do first, convert this minute into degree. So again, how many minutes equal to 1 minute? Sorry, how many minutes equal to 1 degree? 60 minutes equal to 1 degree. So I can write it down. 60 minutes, 1 degree. 1 minute, how much? Clear? So this will be equal to 1. So into 1 divided by 60. So 1 into 1, it's 1 upon divided by 60. So 1 upon 60 degree. Don't calculate it now. Calculate at the last stage. So now you are having a degree. So now again this one. 180 degree pi. 1 upon 60 degree. How much? Clear? So this is equal to 1 upon 60 into pi divided by 180. Clear? See how you are writing like this way. 1 upon 60 multiplied by pi upon 180. Now this we can write in a single ratio in this way. 1 into pi upon 60 into 180. So this is 1 upon 60 into pi divided by 180. So 1 into 3.14 upon 60 into 180. Okay, so now last time few students faced some problem in calculation. Okay, let me tell you one thing here. If it is 3 into 4 into 25 divided by 180 into 7 into 3. If the fraction is in this way, you have to calculate it using calculator. Okay, how you should calculate? Type 3, type multiply by, type 4, type multiply by, type 25. All the terms of numerator you had multiplied, all the terms of numerator you have to divide. Okay, provided here there is multiplication in denominator. So type divide 180, divide 7, divide 3. Clear? See all the terms of numerator you have to multiply. and all the terms of denominator you have to divide. Use in this way to get your answer in one step. Or else use your method that multiply all these three, write down your answer in the numerator. Multiply all these three, write down your answer in denominator. Okay, let's say this is A and B. Now divide A divided by B. This is the second method. Okay, but I prefer this method to get a quick solution. Okay, and I prefer that students you must use calculator, not mobile phone, right? If you're using mobile phone, then also you can, but then you should avoid everything in a single step. 3 multiplied by 4 equal to, multiplied by 25 equal to, divided by 180 equal to, divided by 7 equal to, divided by 3 equal to. Okay, to avoid confusion, use this method. Okay, so if you want to note down this type of calculation, please note it down. How to calculate for further, for future. Okay. Now let's move here. What we have done? 160 minute, 1 degree, 1 minute, how much? 1 by 60 degree. And 180 degree pi, 1 by 60 degree, how much? So 1 into pi upon 60 into 180. So this will be equal to, now let me calculate. Okay. So it's 1 into 3.14, that is 3.14 divided by 60 divided by 180. So it's 0.000290. Okay. Now you can write it in this way. 2.9 into 10 raised to now. How many points are shifted? One, 2, 3, 4. So it will be minus 4 radian. This is your answer. Clear? Remember, I had made this number greater, so it is minus 4. If I was shifting the point on this side, it will be plus. Clear? Now, the third one, C. 1 second. Okay, so now, how many seconds equal to 1 minute? 60 seconds, 1 minute. And 60 minutes, 1 degree. So 60 into 60, 3600. This is the direct conversion of second to hour. So 3600 second, 1 degree. 1 second, how much? So this will be equal to 1 into 1, 1 upon 3600 degree. Now again, the same one, 180 degree, pi radian, 1 upon 3600, how much? So how to solve it? Cross multiplication, 1 upon 3600 into pi. Let me write down directly 3.14, right? And divide by 180. Clear? So now calculate it. 3.14. 1 into 3.14 will be equal to 3.14. Divide by 3600 divided by 180. So it's 0.5 times 0. 485, right? Sometimes this much precise calculation, okay? If your calculator or if your mobile phone is not supporting up to this penny digit after decimal, then you will get error. So that is the reason I ask you to use calculator. So this will be equal to how much? 4.85 into 10 raised to how many points? 1, 2, 3, 4, 5, 6. Okay, so it will be minus 6 radian, right? Clear? So this was about the third one. First, 180 degree pi, 1 degree, how much? For 1 minute, okay? Then for 1 second. Clear? So just note down these three questions. The next one is example number 2.2. Okay, now see, a man wishes to estimate the distance of a nearby tower. A man wishes to estimate the distance of a nearby tower from him. It stands at point A. Okay, let's see. He stands at point A in front of tower C. Let's say this as tower C, and he stands in front of A. Right? He's standing, and exactly in front of him there is a tower, right? And spots a very distant object O. Means from here, in which direction? In the line with AC. Now this is line AC, and from here he spots a very distant object O. Now let's take this issue. Now the word very distant means it is very far, right? Means the point O is very, very, very far, right? Means he is standing here, observing the tower here, this is the tower, and then at a very far distance, straight from here, he is observing or pointing at a distance O. Clear? Now, he then walks perpendicular to AC up to distance B. Okay, he is now walking perpendicular up to distance B. Means this is AC, right? And the perpendicular distance, this is the perpendicular distance 90 degree. So he is walking towards point B. Clear? Okay. Now, see a distance of 100 meter. What is this distance? This distance is 100 meter. Clear? This distance is 100 meter and looks at O and C again. Okay, and he is looking at O and C again. So now, when he is looking at C, it is in this way. Right? So now, since O is very distant, since O is very far, the direction BO is practically same as BO. Okay? The direction BO is practically same. Means now O is not here, it will be appear to here. Now, how does this happen? See, when you observe a moon, clear? Means at this point, I am observing moon exactly at top of my head. Now, when I am moving ahead, right? At present, just assume that moon is directly at the top of my head. Okay. Now, when you are observing, you will also observe sometimes that moon is at the top of your head, right? You will observe up and you will see the moon. Now, when you are moving ahead, okay, let's say you are walking for 20 meters. Now you are not observe that moon is behind. Again, it is on the top of your head only, right? This is happening because moon is very, very, very far. So due to that, it appears at the same position. Okay, same direction. Clear? So what happened? This is very far. So when it is observed from B, it is also observed the same direction. See here. Since O is very distant, the direction BO is practically same as BO. See, BO and AO. These are both are same. Clear? Sorry, it's not BO, AO. Okay, but he finds the line of sight C shifted from the original line of sight by an angle theta equal to 40 degree. So this angle is equal to 40 degree. Okay, so now see here, he is observing from here tower C and noting it for distant object O. He is walking in this way. Again, the O will be appeared same. The line of sight for tower, it's making 40 degree. Clear? Now you have to estimate the distance of tower C from A. So you have to find it out A C. Clear? So now what we'll do? We'll use the trigonometric factor. What is tan theta? Opposite side upon adjacent side means AB upon AC. Clear? So what will be AC? AC will be equal to AB upon tan theta. So this will be AB. What is AB? 100 meter, right? It was given 100 meter. What is tan theta? Tan 40 degree. Clear? So now let's calculate it. What is the value of tan 40? The value of tan 40 will be 0.8391. Now, how did I get this 0.8391? So for that, you have to use the trigonometric table. You might already be familiar with the logarithmic table, right? So similarly, there are trigonometric table for sine and tan also. Clear? For cosine, you just it's complementary of sine, so you can find out if you have the value of sine. And same way for the cot. So that we will study in different video lecture. I will teach you how to find out the sine, how to find out the tan using the trigonometric table. That I will teach you in another video lecture. But at present, just consider that the value of tan 40 is 0.839. So 100 divided by 0.839. So let me calculate it. Okay, it's 119.175 meter. Okay, clear? The answer is 119.175 meter. Clear? So just note down this example 2.2. See, in this case, this is 40, this is also 40. What is it by shifted by 40 means it was in this way. So now it's here. So this angle is shifted by 40, right? It was in C. Actually, it was this way. Now it moves this way. The C is shifted by 40 degree, right? So this is 40. This will be alternate angle 40 degree. Clear? So note it down. Next is example number 2.3. Okay, so now it is based on parallax method. Okay, parallax method. In that, what was the formula? Angle equal to arc by radius. Okay, a far point is observed from two different diametrically opposite point of a planet. Then the angle subtended by it, we are taking it as theta. The diameter, we was taking it as arc, and the distance between them was radius. You had already studied it, okay, in the theoretical concept. It was taught you by Abhishek sir. Okay, so just go through that concept before solving this numerical. Okay, I'm also making you revise the topic. See, the moon is observed from diametrically opposite point A and B. Now, what is observed? Moon is observed. From where? From Earth. So, what I will do, I will just draw. Let's take this as Earth. And what is observed? Moon is observed. Let's take this as Moon. Okay. Now, diametrically opposite point A and B. A and B are diametrically opposite point of what? Moon or Earth? A and B on Earth. So I will take diametrically opposite point. This is the diameter. This is one point exactly on the opposite side B. So this is called diametrically opposite point A B. Clear? What is observed moon? So now from here the moon is observed, and from here moon is observed. So this angle subtended theta. This is the parallax angle. Okay, clear? When you are observing a point from two different positions, then the angle subtended is called the parallax angle, right? If this is a pen, I'm observing from this way, I'm observing from this way. Okay, then it is making an angle in this way. So this angle is parallax angle. Okay, so now what is theta? Theta is equal to 1 degree 54 minutes. Clear? Now given the diameter of the earth to be 1.276 into 10 raised to 7. Okay, let's say I'm writing it here this. Now this diameter AB, what is that? That we will consider as arc. Remember, means here this giving center if we can draw a circle. So this diameter will be taken as arc. Remember, whenever you are solving the sum of by this parallax method, the diameter means if one planet is observed from one other planet, or sun is observed from a planet, a star is observed. Okay, now the diametrically opposite point that you have to consider it as an arc, means as a length of arc. So this I will consider L. And what is its value? 1.276 into 10 raised to 7. Okay, compute the distance of moon from the earth. So this is the distance. So this distance I will take it as radius r. Okay, remember the distance between that two astronomical object will be equal to the radius. The diameter of any one will be the length of arc, and the angle subtended to the other, that will be the parallax angle. Okay, so now what we have to use? Compute the distance of the moon from the earth. Okay, now see theta it is given in degree. Whenever you are going in calculation like angle equal to arc by radius, at that time the value of angle must be always in radian. You cannot use it in degree. Okay, so first we need to convert it into degree. So what was our shortcut? Seconds divided by 60. Here we are not having seconds. So 0 by 60, right? See, I am just devising the formula here. Second divided by 60 plus minute divided by 60 plus degree. This was the complete conversion of degree, right? So second we are not having just 0 by 60, 0 minute 54 divided by 60 plus 1. Clear? This is our shortcut. So second divided by, sorry, minute divided by 60. So this will be converted into degree. So degree plus 1 degree. So 54 by 60, I can write it down as 9, 6, sorry, 6 nines are, 6 tens are 60. Okay, so it's 9 by 10 plus 1. So it's 0 0.9. 0 0.9 plus 1. So it is 1.9 degree. Clear? Now 180 degree pi radian. 1.9 degree. How much? So this will be 1.9 cross multiplication into pi divided by 180. So 1.9 into 3.14 divided by 180. Okay, let's calculate it at the last. Don't calculate it. Clear? So now see what I did, converted degree and minute to complete degree. Then degree to radian. This radian. Okay. Now what is our formula? Angle equal to arc by radius. I'm writing here. Angle equal to arc upon radius. Here I will check the figure. What is angle? Theta. What is arc? L. What is radius? R. What do we need to find out? The distance between moon and earth. So this is R. We have to find out this. So that implies R is equal to L by theta. Clear? So how to calculate R? L. What is L? 1.276 into 10 raised to 7 divide by what is R? 1.9 to 3.14 divided by 80. So I'm writing in denominator, so I'll write its reciprocal. 1.9 into 3.14. Instead of dividing by 180, I will write down here into 180. Clear? See, if it is A by B by C, then this will be equal to A by B into C. Clear? If it is A by B by C by D, then it will be equal to A into D upon B into C. Okay? So this is radius 1.2. Now see how to calculate it. Now just take this as separately. Don't take this in calculation. Apart from this, calculate this. 1.276. Okay, let me calculate it. 1.276 into 180 multiply by 180. Okay, now divide by 1.9, divide by 3.14 because it is in denominator. So this is 38.498 into. Now see, we didn't took this in calculation. So this will be directly into 10 raised to 7 meter. If it was in denominator 10 raised to 7, then I will take it in numerator 10 raised to minus 7. But it's a numerator. So now the standard format is decimal after first point. 3.8. Let's take it round figure. 5 into 10 raised to, I have shifted one number here. Clear? So it will be 10 raised to 8 meter. Sorry, one point. Whenever you are shifting the decimal in this way, right, on a left, then you should increase the power. Whenever you are increasing the decimal, moving the decimal towards your right, then you should minus it. So your answer is 3.58 into 10 raised to 8. Clear? So just note down this example. The next is example 2.4. Now here it's given that the sun's angular diameter is measured to be 1920 seconds. Okay, so now what you have to do, take sun, earth. Now this will be the diameter of the sun. Okay, when it is observed from earth, okay, it makes an angle. So when two diametrically opposite point of sun is observed from a common point of earth, then it makes the diameter, and that is called angular diameter. Okay, so here this theta is parallax angle, that is angular diameter. This is length of arc, we will take diameter as length, and this is r distance between earth and sun. So what is given? Theta 1920 second. Now the relation is already given in the question. 1 second equal to 4.85 into 10 raised to minus 6. So this will be 1920 into 4.85 into 10 raised to minus 6. Now what is the diameter given? Means length of arc. Sorry, that you have to find it out. The distance of D from the earth. So R we will take it as D. So R is equal to D, and that is equal to 1.496 into 10 raised to 11. You have to find out the diameter of the sun, means L. Okay, so you have to find out the diameter equal to L. So D equal to length. Okay, now we are in the formula angle equal to arc by radius. So what is L? Theta into R. What is theta? 1920 into 4.85 into 10 raised to minus 6. And what is R? 1.496 into 10 raised to 11. Okay? So now for calculation, just separate this. Don't take consider this in calculation. Okay? So calculate the other thing. So let me calculate it. 1920 multiplied by 4.85 multiplied by 1.496. It's 13930.75 into 10 raised to. Now see, base is same, power 11 minus 6. So 11 minus 6, okay, it will be 5. Clear? So now standard format 1, 2, 3, 4. So diameter of sun equal to L 1.39 into 10 raised to, I'm shifting on left, So I need to add it 5 plus 4, 9 meter. Okay, clear? So just note down example 2.4. Okay, students, so that's it for today. Thank you.